Welcome to September's first LeetCode challenge, array nesting. You're given an integer array nums of length n, where nums is a permutation of the numbers in the range 0 to n minus 1. You should build a set S at index k such that it is equal to the set of nums at index k, nums at nums index k, nums at nums at nums index k, subject to the following rules. So we can see that these are nested types of arrays. So the first element in the S at index k should start with a selection of the elements of the nums index k of index equal to k. So that's just basically saying, you see the nums here, this is index 0. Index 0 should equal to 5, or should point to 5, right? The next element. The next element, S at index k, should be nums at nums index k, then so forth and so on. So it's being nested there. The arrays are nested. We stop adding to the right before the duplicate element occurs in S at index k. Return the longest length of a set in S at index k. So let's give it a bit of an example here. I'll highlight this nums index here, and we have the following. I'm just going to make it easier by basically labeling the index. So we see that we have index 0 points to 5. 0 points to index 5. And we see index 1 points to index 4. We see that index 2 points to 0. So actually index 2 points to 0, so I'm actually going to bring it right here. So index 2 points to 0. So we don't need to make a new list, a new cycle, a new grouping. We see index 3 points to 3, so 3 itself is isocyclic, so I mean that 3 points to itself, so the largest length of itself is going to be 1. And we see that index 4 points to 1, so 1 points to 4, 4 points to 1, therefore this cycle is completed, right, because they point to each other, right? And it's a cycle there, so every time we go to 1 going to 4, 4 goes to 1, it's already cyclic, so the largest grouping of this element of this cluster is going to be 2. We see that index 5 points to 6. Yeah, 5 points to 6. And we see 6 points to 2. Right, and this is a cyclic element as well, cyclic group cluster. And the largest length of a set at S index k is going to be 1, 2, 3, 4. This is the largest cycle we have, cycle length, and therefore we return 4 as the output. So that's basically the estimation for the top one. Likewise, we see here index 0 points to 0, index 1 points to 1, index 2 points to 2, therefore the large element itself is 1 cluster, which is, it points to itself, which is going to be output of 1. Very similar to the 3 we have here, 3 cluster. So in order to solve this, there's a couple ways, but the first one I'm going to do is I'm going to keep track of a visited array. Using a visited array, I'm going to keep track of things we visited, and then we're going to basically keep track of it that way and find the largest, use a kind of a depth first search algorithm to find an element within the array. So one thing about this is all values and nums are unique, which is great. So therefore we could use this type of approach. The elements in the same set will form a cycle. We're just going to traverse each element in our nums array. If X is not in the visited, we're going to use depth first search to put the element into the same cycle of the node X. Update our output if the current cycle is length greater than our answer, our output I should say, and just basically keep track of the count of the number of cycles. So let's go about doing that. So the first thing I'm going to do is to find the length of nums. So n is going to be the length of nums. And then I'm going to make a visited array, visited, and that's going to be Boolean, so false, times the size of n. visited, and then I'm going to have an output, and that's going to be initially 0. And for each element, I'm going to call it x in nums. I am going to keep track of count, which is going to be 0. So this is going to be counting our cycle, right? Our cycle, or the largest grouping we have. So while not visited, so while the element is not visited at x, we are going to increment our count. That means it's already counted. We're going to update our visited array at x to be true. And we are going to assign x to be the nums at index x. Right? This is our nesting statement here. Then we're going to update our output to be the maximum between our output that we have and our count. And then in this, we want to return our output. All right, let's run this. Variable n nums. For accept, let's see, submit. Accepted. So this is time complexity of big O of n, because it's equal to each element in nums. N is the size of the length of nums. Space complexity is big O of n as well, because we store everything inside a visited array, and that's of size of length n. We can modify this a bit by making it constant space. Instead of having a visited array, what we're going to do is we're going to basically directly change update or the actual nums array originally. So how we're going to do that? So we don't need any of these. We don't need to keep track of the length or the size or the visit array. For nums at index I, we're going to still keep track of our count. However, we are going to say if x is equal to so the length of nums at index I is between 0 to the length of nums. So let's call it a negative number 1. If that's the case, then we're going to continue. Otherwise, we're going to make count equal to 0. So while, let's change this up, while nums at index x is not equal to negative 1, because this is the flag, a Boolean flag we're doing. Instead of true or false in the visit array, what we did before, we're going to change it to negative 1, the actual element. And while if it's not negative 1, what we're going to do is increment our count. We are going to change nums at index x to be negative 1. We're actually going to put this on the same line because it needs to be done at the same time. So now and then we're also going to update nums at index x to negative 1. And we're going to update x to be nums at index x. We're going to do return output. And let's run this. And this should be also for time complexity is big O of n as well, because you still have this for loop for n, where the size of n is the length of nums. But space complexity now is constant space, because we just make everything, we change the nums array originally just by changing it to a negative number, and that's how we keep track of whether we visit it or not. All right, that's it. Have a great day, guys.